How to find the heat of solution of sodium thiosulfate crystals. This is experiment 4. And in the laboratory, determining the heat of solution of various compounds is actually essential for understanding the thermodynamics and the energetics involved in chemical reactions. Now, thermodynamics has to do with transformation of energy, that is heat energy, during chemical reactions, and it has to also get to let us understand how spontaneous or the extent to which the chemical reaction is occurring. And energetics, on the other hand, has to do with transformation and transfer of energy that takes place as reactants are getting to form products. And it has to do with the enthalpy. It has to also do with the Gibbs free energy, activation energy, bond energy, all of that. Energetics actually helps us to predict the nature of a chemical reaction. Now, one common method to determine the heat of solution is by using a calorimeter. So a calorimeter we provided, then we know sodium thiosulfate is actually a versatile compound that is used in industries, specifically in photography, water treatment, and pharmaceuticals. Now, by following experimental procedures, we can be able to measure the energy change, which is the enthalpy, associated with the dissolution of sodium thiosulfate crystals using a calorimeter. Now, the question we are to ask ourselves is, what is heat of solution? Okay, heat solution is the energy, or you can say the enthalpy change, that occurs when a solute is dissolved in a solvent to form a solution. Now, to carry out this experiment is pretty simple, but then the step 1, you're going to have a calorimeter provided, so you should be able to measure the mass of the calorimeter. The calorimeter that we provided, first step, measure the mass of the calorimeter and record it as M1. Step 2, you take a certain mass of sodium thiosulfate, say 8 grams, okay, and measure or weigh the sodium thiosulfate that has been provided for you. And you record that value as M2. M1 mass of calorimeter, M2 mass of sodium thiosulfate. Now, step 3, add a given volume. From your manual it says 100 ml, okay, of distilled water into the calorimeter. All right, now before you add that distilled water into the calorimeter, ensure that the water has been warmed up to temperatures around 38 to 40 degrees Celsius before you add the distilled water into the calorimeter. So once you've added a given volume of water, 100 let's say, that has been heated to about 38 to 40 degrees Celsius into the calorimeter, the next thing you to do is to measure the initial temperature of the distilled water in the calorimeter. So once you've added the distilled water into the calorimeter, just with your thermometer fixed, okay, take the initial temperature of the distilled water in the calorimeter and you record that as T1. Now, step 5, you carefully add the weighed or the measured sodium thiosulfate crystals into the calorimeter containing the solvent. So you are adding the solute to the solvent to form a solution. That is step 5. Now step 6, start stirring the mixture. That's You just start stirring the solution in the calorimeter until it completely dissolves, and you get to observe. As you're stirring, you're observing the thermometer to check for the consistency or the temperature at which the temperature of the solution is constant. Okay, where you observe a constant temperature while you're stirring, okay, you record that value as T2. So M1 mass of calorimeter, M2 mass of sodium thiosulfate, then T1 is the initial temperature of the distilled water in the calorimeter. Then we have T2, which is the temperature of the solution, where you observe a constant temperature after having dissolved the sodium thiosulfate in the solvent. And that is step 6. Now step 7, you measure the final mass. You're going to weigh the final mass of the calorimeter and the dissolved sodium thiosulfate in distilled water. So once you've gotten your T2, just weigh the calorimeter and the sodium thiosulfate that has been dissolved again. So that mass, you record it as M3.